Hello, everyone. My name is Kate, and I'm a new member of the Max marketing team. We'd like to welcome and thank you for coming to our webinar on manufacturing control systems. Just so you know, we will be recording this session. If you have any questions during the presentation, please submit them in the Q&A panel at the bottom of the screen, and we will address as many of them as we can in the final 15 minutes of the webinar. It is my pleasure to introduce you to Rick Alger. Many of you may know him from his 25 years of experience in the manufacturing industry. He recently joined us in January as the Director of Professional Services at Max, and he is also an APICS Certified Associate Instructor for the CPIM certification program. Rick, I'm handing this off to you.
Great. Thanks, Kate.
Sure.
And welcome, everybody. This is the first webinar I officially have done with Exact in this new role, so I'm kind of excited to share this with you. One thing that Kate didn't mention is that I am working out of my home office in Eastern Tennessee. So at the end of this presentation, there'll be some contact information. And even though my office exchange will be 650, which is the San Mateo, California exchange, I am on Eastern Standard Time, so keep that in mind when trying to reach me through communications. Today we're going to talk about one of my favorite topics and something that I've written on whiteboards and I don't know how many hundreds of organizations. I just refer to it as a manufacturing control system. The manufacturing control system is the fundamental model that not all ERP systems, but most ERP systems are based on. So if you're studying ERP and you're studying ERP that has been originating in a manufacturing environment, and just keep in mind that not all ERP systems originated in the manufacturing sector. When you're looking at ERP in the manufacturing sector, the core planning mechanism that's in this model is basically its roots. Now, when we look at the models, they all look differently, and they look differently for several reasons. First of all is the author. Like the model I'm going to show here is the model I drew out on a piece of paper as I was studying for the APICS CPIM exams back in the 80s. So it's something that as I was learning the concepts, I was drawing the picture so that I could meet my learning style. The second is use. This is an operations model. So we're going to use this model to talk about Max as a planning system. Max is an operations management system. If I were meeting with a financial group, I would use a different model that may have many of the same components, but instead of planning all the way down to the bottom as far as shop floor and then talking about capacity, I would talk about a lot of the same operating modules linked to the accounting modules of AR, AP, and General Ledger. So there's different models for different purposes as well. Learning this model will teach you how to see the system, how to think about the system, maybe put some pieces together for you. And out of the three words, manufacturing control system, the most important word is control. So by learning this model, you'll learn some of the basic control points we have as managers to better manage the implementation of your system. So the session outline is pretty simple. We have 1 hour, and we're going to really talk about two things. I'm going to show you the operational manufacturing control system model, and we're going to step through it piece by piece so it all comes together. And then at the end, I'm going to show you a larger version of the same model that's more from the APICS. I mean, this is all APICS material, but APICS uses a little bit larger model because it expands beyond the software. One of the reasons I use the operational MCS is because it cuts out some of the things that there are no modules for. Okay, and then as Kate said, at the end we're going to have some time for some questions and answers, and we'll conclude with that. We'll try to stay on time, which is always a goal. So as we get started here, let's talk a little bit about models and modules. Models are used to explain complex and abstract systems. They can show us relationships, and they can be used to discuss how the system works. Like we can actually turn on an ERP system and kind of watch it but we really can't see how it all works because it's all bits and bytes running at a computer software level. So we can create models to discuss and create narratives about what's going on inside of that code. Modules are the actual code. And sometimes modules have the same name as the component in the model. So it becomes confusing of which we're talking about, the models or the modules. And in this lesson, we're more concerned about the model, not necessarily the modules. As we get deeper and deeper into discussion, though, almost always we end up talking about the modules, the software, because most of us in this session are actual Max users or work for Max organizations. We do have a few prospective Max users in the group, so they're looking at different ERP systems. But as we drill into the detail, you almost always at some point move into the actual software that you're looking at. And that's okay, but we're going to try to keep this at a higher level and talk about the models. Now, why do we use models? We're going to use this model to really go through 4 different areas. We're going to talk about planning versus execution. We're going to talk about time horizons and level of detail. We're going to talk about the roles of material and capacity planning, because they are 2 separate elements. And then we're going to go through fundamental descriptions of the 9 major functional areas of the model. And we have to do it all in about 45 minutes, according to my boss, Kate, which is plenty of time. So we're going to kind of start with a blank slate here. And on this blank slate, we have one horizontal dotted line across the lower 2/3 there. And that dotted line separates planning at the top of that line from execution at the bottom of that line. Planning is the aligning of all of our resources. And if you remember from Intro to Administrative Studies is what they called it when I was in school, but there's 4 M's that are aligned with resources. Those 4 M's are material, manpower, machinery, and money. So planning is about aligning all those resources across the lead times. Now notice over on the right, we have a vertical arrow, and at the top of that continuum, we have a long term, and at the bottom, we have short term. So when we talk about lead times, we're talking about from now to some point into the future. Now, naturally, planning is a longer term function. Execution is a short term function. So we actually see that on this slide. One of the rules about being successful with a manufacturing control system is that your minimum planning horizon must cover the longest cumulative lead time. Now, longest cumulative lead time means the lead times of all your purchase parts, plus all the lead times through each level of your bill of material, all the way up to your end item. So if we have, say, 16 weeks for purchasing, and it takes another 4 weeks after we get all the parts in to actually produce it, we have a cumulative lead time of 20 weeks. That 20 weeks establishes our minimum horizon for planning. So if our customer orders only go out 4 weeks, that means we have to forecast the remaining 16 weeks. Otherwise, we're never going to get ahead of the curve. Okay. Now, on the next slide, we're going to draw a vertical dotted line. And in the vertical dotted line, on both sides of the vertical dotted line, I should say, we have material to the left and capacity to the right. So the components that are going to fall in the top left quadrant are going to be planning components involved with materials. Those on the top right are going to be planning components aligned with capacity. And then as we cross the horizontal line into the execution phase, we're going to have execution material and then execution capacity components as well. So I hope you can see it, how it's all going to lay out here. It's relatively straightforward. So let's start with the very first planning component, and that's called SOP. SOP is sales order processing, and it's concerned with capturing the independent demand accurately, and more specifically, independent demand coming from customers. So the word independent means that it's not really related to anything. We can't predict reliably when customer orders are going to arrive. They pretty much just show up. The other type of independent demand would be a forecast. where we guess what's coming. And we all know what the number one rule of forecasting is, and that is that they're always wrong. So we're trying to capture independent demand up here, especially from the sales orders that represent promises that we make to our customers. So it involves activities like customer service, quoting, the actual entry of that sales order, and the promising of that sales order, and often shipping. As this actual sales orders are entered, they're actually passed to the master production schedule if we're using master scheduled parts. And if we're not using master scheduled parts, they are seen by the MRP that we can actually drive the lower level components, the lower level bill of material levels. Now, this is a simple model, and we keep it simple on purpose, but there's a lot of interfaces I want to introduce as we go through this that are not shown on here. And in this case, the interfaces around sales order processing includes things like web stores. There's a lot of companies who are booking customer entered orders onto websites, and they flow from the web store directly into the software. It also includes customer relationship management systems, electronic data interchange or EDI systems for inbound sales and schedules, and for outbound advanced ship notices and invoices. There's advanced forecasting systems. There's shipping systems. And in some cases, radio frequency identification systems, or RFID. And then naturally, we have invoicing and accounts receivable systems. So all these concerns flow around this box called sales order processing. To the right of sales order processing, we have master production scheduling. Master production scheduling establishes the rate of production. And the production plan is the main output of a sales and operations plan, which I'll show you later on when we get to the other APICS model. The master production schedule is a statement of supply for each end item, and in this case, each end item that we're selling, if we assume that. The fundamental rule here is that your supply must equal the demand for the period with respect to the available capacity. So for each customer order that's coming in, it has a part number, a quantity, and a due date. They're the three most important fields from a planning perspective. And then the sum of the quantity for that particular part in whatever period of time you're determining your schedule to be, whether that be weekly or biweekly or monthly, that has to be balanced out with a schedule. So supply is always equal to demand. That's the job of the master production scheduler. Whatever we decide to schedule in terms of the master production schedule, it's said to drive MRP, and you'll see that as we progress through the model here. So we have a fundamental issue here that a lot of companies have a hard time reconciling, and that is, should we insert a human planner into the system at this level or not? And there's two schools of thought here. School of thought number one would be, yes, let's go ahead and put a master scheduler in. That means we have a human sitting in a chair with a title called master scheduler, and that human is responsible for creating the production plan. They balance out all the sales orders, they balance out the forecasts coming in, they balance out the available capacity, they make decisions about what is the most important for a period of time, and they're constantly rescheduling things around so that the plan is the most productive. Option two is that we don't have a human in that chair. That chair may not even exist. And instead, we use what we refer to as demand-driven MRP. Demand-driven MRP simply says that we enter the sales orders into the system, and the sales order drives the MRP system. So in that situation, your order processors become your factory schedulers. And you have to think about that. How good are your order takers, and have they been trained in actually scheduling a factory? And if the answer to that is no, you may want to contemplate using a master schedule, even if you're in a make-to-order environment where demand-driven MRP is a common tactic. As we cross over to the right now and into the capacity realm, we have a box called RC capacity. And RC is abbreviation for rough cut. Its primary purpose is to keep the master production schedule realistic in terms of what our capacity is, or our capability to produce. There's two types of capacity planning systems when you're studying ERP. There's those that are infinite capacity planning and those that are finite capacity planning. Infinite capacity planning systems are just that. They assume infinity. You can schedule anything you want. I always said, well, you can enter an order for 1 million pieces tomorrow and run the MRP, and it will generate what you need to build those 1 million pieces without any regard to whether you have the capacity to build 1 million pieces tomorrow or not. That's kind of the worst case scenario of an infinite capacity planning system. When you talk about finite capacity planning, that means there is a theoretical limit of what you can do, and the software system will actually plan to that level. So with infinite capacity planning, we don't specify how many resources we have in detail because it's just a theoretical line anyway. But with finite capacity planning systems, we have to be very specific on what's the capacity of each work center, what's our load on those work centers, because the finite capacity planning system will not let us exceed our available capacity in any one period. It'll push things out. Now, in order to use rough cut capacity, the recommendation is to use the part routing data, which I haven't introduced yet. That's going to be down in the shop floor execution box, so I'll mention that again when we get there. But we can produce rough cut capacity data from the same data that we're going to enter into our routings. So the same times that are used for production control product costing can also be used for capacity. So it's recommended that we implement shop floor execution at least to that level, to where we have the runtime hours available to look at our capacity data. So at this top level, we have sales order processing, which is capturing all the demand. We have master production scheduling, which is balancing those. And then we have rough cut capacity, which makes sure that we don't overschedule our facility. Dropping down to the next level now, we have a component called bills of material. Bills of material are a couple things. First of all, it's a catalog of all the parts that we use in the system. Some systems call that an item master. Max happens to call that a part master. But basically, it's all the parts that we're using and their corresponding component part strategy. The component part strategy includes decisions like, are we going to make it or buy it? Well, what are its lead times? What are its costs? And how are we going to derive those costs? What are the planning policies? All that stuff is rolled up into the item master or the part master. It may also include manufacturer's part control information for commercially available parts if we're in an industry that relies on that, like the electronics industry. The BOM record itself contains information on how the products go together. They're the parent component relationships and the timing of those relationships, which most systems call an effective date. So a parent and a component and effective date create a unique record that specifies a quantity to be used for that period of time. These relationships set up what we call the dependent demand, but it's required by MRP. And a fundamental distinction of MRP is don't guess at it if you can calculate it. So if I know I have X amount of pieces scheduled through my master schedule, and I know what the bill of material is for what I need to build those pieces, then I can calculate how many of each part I need through a simple mathematical calculation. That's called the concept of derived demand. That's what MRP is based on. A key area of concern in bill of materials is accuracy. And I don't need to say the garbage in, garbage out word, but we all know how that works with systems. So if we can't get our engineers to structure our BOMs accurately, then that calculation that we can do so easily using an MRP module, it's just going to generate bogus results. Interfaces around this area include computer-aided design or CAD systems. There's integrations with AutoCAD, which was the original one, and there's now interfaces available with SolidWorks where you can push 3D models directly into the bill of material and part master. Engineering change management systems are found here, as well as document management systems. Next, we have this little box called inventory. Inventory is probably one of the easiest on this, maybe second to purchasing. They seem to be concepts that most companies get fairly easy. Inventory basically is the result of everything else you do with this system. So therefore, we can measure how effective you are with this system based upon your inventory relative to your level of sales. And there's some financial ratios we can use to determine that. They can be backwards engineered to say for a certain size company, how much inventory should we have? And those should be targets of which we use to improve the system and track how well we're actually doing in our implementations. Inventory component here is concerned with establishing stock rooms and the quantity stored there. But this particular component is not concerned with work in process inventory. It's only concerned with stockroom inventory, which could be raw materials, semi-finished goods, and finished goods. Also in this box, we have safety stock concerns and protection against uncertainty, reorder point control. Not every part needs to be reorder point or MRP planned, and floor stock systems, which means every single part doesn't have to go through a kitting process. And because the inventory is a result of transactions, you know, the ins and the outs, kind of like your checking account, you know, in your local bank. Transactions must be designed and controlled under an inventory transaction processing system. So that means we have to specify specifically when are we going to do each one of the transactions and how should they be done so that the inventory stays accurate and so that the accounting of that inventory stays accurate. And in some industries, there's a subset of software or functions underneath this inventory that includes lot and serial tracking and recall management. And here we also have an accuracy concern. We have to be, whatever we have in inventory has to be accurate in terms of the MRP processing, planning for the right parts. Interfaces here include data collection systems, auto replenishment systems or ARS, where we can scan an item and have it show up as a purchase rec in purchasing, consignment, where we're shipping parts out to customers, but they're not paying for it until they actually sell it, and warehouse management systems. Next, we have the actual MRP itself. And MRP stands for Material Requirements Planning in this terms. And I always just call this the heart of today's MCS. So if we were on a whiteboard, I'd put a little heart over that little box there so we know it's kind of like the center of the system. And MRP is basically a mathematical calculation that the computer is much more able to do than any human. And I'm going to recite that formula for you just so you get an idea of what's happening. And if you look at this model as I specify the formula, you can actually see the formula happening in this model, which is one of the reasons I like this model. And that formula basically says take the master production schedule quantities and multiply it by the bill of material quantities. And as you're doing that, offset the difference between the two in dates, you know, by the lead times. That will create what we call a gross requirement. Then subtract off the on-hand inventory, that's usable inventory, and that's a term called nettable. We're going to subtract off the on-hand inventory. We're going to subtract off any scheduled receipts from the purchasing and shop floor areas, which I haven't put on the model yet, but they're down in the execution. That's a sign of what's coming. And the result of that equation is then a net requirement. And if that net requirement is positive, MRP needs to generate a planned order to fill that hole. That means we have more on demand than we have supply. MRP's job then is to balance that supply and demand by generating a planned order to bring it back into balance. Now, there's two major outputs of MRP. One is a series of planned orders, which we're going to execute going forward. That is our plan. It just hasn't been approved or released yet. And we have exception messages for anything that's already in existence, like pull this purchase order in, or this push this shop order out, or de-expedite because we no longer need either one of those orders. So MRP is what's keeping all this tied together. Most companies put that on a schedule and it just runs on a server at some standard time interval, whether that be every night or once a week or whatever your interval happens to be for your organization. Crossing across that bottom horizontal line there now, we're moving into the execution phase. And this execution phase is, this next component is purchasing. Purchase control is taking the planned orders as a result of the MRP and assigning them to a vendor. And as we are assigning them to a vendor, we make them a purchase order, which is a commitment to our vendor that if they ship us these goods, we will pay them for those goods. So the planned orders You can run them through purchase requisitions if your company requires it, or you can run them directly into purchase orders. Those purchase orders stay open until they are received on your dock, and then as we do that receipt to stock transaction, if it's a complete shipment, then that line on the purchase order closes and it shows up as on-hand inventory. So the plan that came out of MRP becomes executed through the purchasing process, and it ultimately ends up in inventory, where then it can be issued back out to a shop order if it's needed for the next level up in the bill of material. We have a concern in the execution phase for order accuracy, and almost everywhere I go, we have issues with open purchase orders, especially with regards to past due dates. And those of you who have worked with me know how I feel about that. It's not a good thing to have chronically past due dates anywhere in your manufacturing control system. Interfaces down here are accounts payable, quality management systems, especially when it in regards to incoming inspection, and sometimes supplier portals where the suppliers can log on and actually get their own data that they need to support your plan. The other execution function is shop floor execution, and this is where I was speaking of the part routing back when we were talking about bill of materials. For each make part that's used in the bill of material, it's assigned a part routing that identify the production sequences for that particular assembly or for finished goods. And then in that sequence, it specifies what work center is used to produce that particular step of that part, and the series of the work centers. It could go from a cut to a bend to a weld to a paint work center in a particular routing for a fabricated part. Inside of that routing, we specify how long it takes in each work center, and we refer to that as feeds and speeds in a lot of places. And it's that run time and some setup time, if there are any, that is actually used to do some rough cut capacity planning if we want to. I mentioned that the inventory module wasn't concerned with work in process. That's because work in process in most systems are inventory that have already been issued to open shop orders. So the work in process management is a main part of shop floor execution, or vice versa. In effective organizations, shop orders are opened and closed within the lead time that's specified for that particular part. It's not a good idea to open up shop orders and have them sit on your system for 90 days or 180 days, unless that's truly the lead time that you have in your part master for that item. If a part has a 10-day lead time, orders should be released on maybe day 15 at a stretch, and within 10 days they should come back off your floor as complete. The lack of WIP control is one of the major causes of poor ERP system performance or manufacturing control system performance, because as WIP increases, raw material inventory increases, throughput decreases, finished goods get starved, and customer service decreases. So it's a whole bunch of effects going in the wrong direction simply by having WIP work in process be out of control. Shop floor execution, like purchasing execution, has an order accuracy concern, in that shop orders must be accurate in terms of their part number, quantity, and due date, in terms of where they are relative to the floor, and in terms of accurately reporting if you're going to report labor back. The interfaces down at this level include data collection systems, time and attendance and labor tracking systems, lean manufacturing tactics plug into this area, and computer numerically controlled devices for like downloading drawings into a brake or into a plasma cutter, and also some programmable logic controllers where your machines actually talk back to your ERP system. And finally, down here in the execution part of capacity, we have a box that's simply labeled priority. So priority is basically a short-term priority planning. This was originally called operations sequencing back in the day. I think that was a term that was coined by IBM back in the old IBM APICS mainframe days. But priority just seems a lot easier for most people to understand, so that's what I use in this model. Priority is critically important, and it's critically important for one reason. The operational MCS that uses MRP as an engine is concerned with one thing, and that is maximizing the efficiency of the shop floor. And how it maximizes the efficiency on the shop floor is that it pushes work in front of every single work center so that the operators, number one, never run out of work. And number two, where there's jobs that are very similar, they can either combine setups or they can have very minor changes to existing setups in order to process the most orders. That's what MRP does. It tries to maximize efficiency. It's not the same as trying to minimize inventory. The minimization of inventory is a goal of lean manufacturing. And that's where you'll find some conflict between the philosophies. And talking about manufacturing philosophies is a whole other hour. But just keep in mind that we're trying to maximize efficiency, so we're going to push orders to the floor. We're going to stack up the queues in front of the work center. Now that we have those queues in front of the work center, we have to have a way to determine which one to do next. That's what the priority box is for. And again, systems like MAX determine the priority based upon the due dates. If your due dates all throughout this model are hosed, good luck trying to determine what's important. And the system will break down and people won't trust it, and you'll get into all kinds of issues. Only because somebody in the organization can't say, I need to keep my due dates accurate. Okay, so here's the final model. Can you see the MRP formula? Again, I'll state it. It's the master production schedule quantity times the bill of material quantity offset by lead time equals gross requirements. Gross requirements less on-hand inventory that's usable or nettable, less any scheduled receipts, which are the open purchase orders and the open shop orders, give us what we call a net requirement. If the net requirement is greater than 1, MRP plans an order. Like this by stating that formula, and those who are around this model all the time should just have that memorized. You can see MRP working. Okay, so this one last concept here, and we've kind of used up our time anyway, and that concept is that this is a top-down planning, bottom-up feedback system, and it's a closed-loop system. So what that means is that we start at the top with the production schedule, and we work it down through all the levels of the bill of material, and we offsetting that by the lead times, and in the short term, we're sending those orders to the execution phases, and we're executing those, and it's coming back into inventory, and things are kind of working themselves through the system. As soon as we find a situation that is no longer acceptable, let's say we have a big job that's supposed to be shipped out in the middle of May, and we can't get the purchase parts until the end of May. What do we do? Well, the bottom-up feedback loop says, well, the purchaser should go to the scheduler and say, I can't get these parts in. I've tried everything. It's not going to happen. And there's ways of expediting beyond some lower-level buyers, but let's assume that it really isn't going to happen in this case. What the master scheduler should do is take that top-level master schedule and push it out to when that part's going to come in. And by doing so, it will de-expedite or push out, not de-expedite, just simply push out all the other purchase parts in that same bill of material. So therefore, we won't be receiving any inventory early, that all the inventory will come in balanced. And if that requires us to repromise the sales order, it's better to do that now than to wait and hope that the parts are going to show up and end up not shipping that order on time anyway, and then telling the customer the day before that they're not going to get their goods. So anytime there's a situation in the execution phases, it has to be elevated back up to the planning stages, and those actions have to be reconciled. Critical part of this, and that's an area where a lot of companies struggle. It's better in some cases, according to some thinking, to bring all the parts in and let them sit on the shelf. That way they'll be there when I eventually get the part that I need. And that's really not how the system is designed. When allowed to function properly, this system will plan and replan and balance supply and demand across the time. But humans can really mess that up if you let them. The APICS model. If you take a look at this model now, and if we start at the bottom and work up, you'll see that most of it's the same. The first difference that we see coming up is that what used to be called sales order processing is now called demand management. APICS has a larger definition of what that particular component does. And in most of our software systems, that's simply sales order processing. And then above that level, we have sales and operations planning. Sales and operation planning is linked with resource planning, which these are longer term. Sales order processing, Sales and operations planning is a horizon of maybe 1 to 3 years, where a master schedule may only go out to be a year for some companies. So the S&OP level is looking at a longer horizon, and it's making sure we have the long-term plant and equipment type of resources available in that horizon. Now, there's 3 components of a sales and operations plan, which includes a sales forecast, a production plan, and capacity. If you ever worked through a sales and operations planning process, they're kind of like the 3 building blocks that we're trying to balance to determine what families are we building and how many of each, and how is that going to affect the overall capacity and production. Above that, we have business planning. Business planning is even a longer scale, 3 to 5 years, and that sets the overall business objectives. You know, what's our sales going to be? What kind of marketing plans do we need? What kind of financing do we need? How many people do we need? It's much longer term of planning. And then working from the top down, again, the time horizon becomes shorter and shorter. The top of the model where you're concerned with business planning is 3 to 5 years. Shop floor is like, what are we going to run on this machine after this job is done? So the horizon, the time gets smaller and smaller, shorter and shorter. And the level of detail gets greater as you go down. So with that, I want to conclude, and before I do, I want to thank you again for being here. There's lots of different ways of seeing these systems, and this is just one way. Actually, it's 2 ways counting the APICS version of it. This model is what I've inserted into all the courses that I developed on the exact software over the years. And as you study ERP systems, ask, like, from a software perspective, what module, if any, does this topic fit into? And where does this topic fit into each model? And how does it impact operations, accounting, and implementation? Like, there's different pieces of all of this. We can just continue to talk about it for hours and hours and days if we really wanted to. The next thing I would recommend to everybody, though, is a conversation on manufacturing environments, because this manufacturing control system is the same pretty much for all manufacturing companies. The tactics that are used inside of this model change based upon the environment that you find yourself in. And the environments, I mean, make to stock, assemble to order, make to order. So a make to stock company using this model will be using different tactics than a make to order company using the same model. So watch for that. We have a webinar being planned for that coming up, I believe, in late June or early July. So keep your eyes out for that, because that would further develop your narratives around this model.
Thank you again for coming, and we hope you have a great rest of your day.